My name is Jason Davis, and I run product management at Backtrace.io, a Unity verified solution partner. In this session, I'll be covering how we can help you deliver better games faster with next-generation crash and error reporting. Game errors and crashes are inevitable. They're going to happen to your players either during playtesting and beta cycles or after you've released and it's out in the wild. So the question for you is, how fast can you detect and resolve the problems that matter most? In this session, we're going to spend time helping you answer that question. We'll start off with a brief introduction to game crashes and errors. What are they and who cares? Then we'll highlight a bit about what Backtrace is and how we help, how we integrate into your games, collect information, and present it to you in a way that allows you to slice and dice and triage and understand the issues that matter most to you. We'll walk through a few screenshots showing you how people leverage Backtrace, prioritizing by factors important to them, and performing advanced analytics in order to help get to the root cause and identify interesting patterns. We'll start to close by discussing how different game studios have been using Backtrace throughout their game development lifecycle, and then we'll wrap up with brief summary statements of what we discussed. So first off, game crashes and errors. What are they? Well, they manifest themselves as shutdowns, or hangs, or restarts, or just general problems in your gameplay. Really, crashes and hangs are the worst. They interrupt the gameplay experience, and they're really annoying to players. So the causes of crashes and hangs are really numerous. They could be programming errors. They could even be networking issues, though, or faulty hardware, or misconfigurations, or invalid device drivers. Many different types of issues. So as a result of a game crash or an error, the players themselves get annoying. You can see bad reviews, bad publicity, see a lower uptick in player retention. So game crashes and errors can really impact the bottom line and the play experience. Who cares about game crashes and quality? Well, players do and users do, right? So almost 80% of users or players are going to review ratings and reviews before downloading their app or game, right? And more than half are going to check those reviews again before making in-app purchases. So for all those game developers who are building free-to-play games or games that monetize while they're being used and making use of in-app purchases, game crashes and errors, which can lead to bad reviews, can impact the ability for you to onboard new players. Beyond that, technical directors, lead programmers, game producers, pretty much anyone who's watching this talk here should also care, right? And why is that? Well, again, players are reviewing their stats. And if you have a high-quality game, 4 or 5 stars, you have much more of the market available to you. So over 90% of players will download a game or an app with 4 or more stars. But if it's a 3-star app, only 50% of users will. Game crashes and instability can lead to poor ratings. It's one of the key factors that can lead to poor ratings. So your users care, and as a result, you should care, because the less crashes, the less errors, the better the gameplay, the more of the market is available to you. So Backtrace was designed and developed to kind of solve this problem. The company itself and the product is over 6 years old. We started off working with ad tech and Linux servers and other native devices, and we've moved into game consoles like PS4 and Xbox and Nintendo Switch, mobile devices like iOS and Android, and PCs, Windows, Mac, etc. We provide the data and workflows that developers and programmers need to act upon the crashes and stability issues that occur on these platforms, and those issues that are impacting your bottom line. So Backtrace, as I mentioned before, is a Unity verified solution partner and a recommended solution for improving game stability. We work closely with the Unity team to ensure that the library that we provide, our plugin, is certified and works well with all of the long-term supported versions of Unity and all of the platforms that Unity supports. We provide automated crash and error capture across the complete game development lifecycle. Crashes and errors include things like non-fatal errors, actual crashes, hangs, and other general errors that occur across all major platforms. So some of you may be familiar with this type of product for mobile games. We've seen a number of companies that have done this and focused on the mobile iOS and Android games, right? But Backtrace is really the only platform that is truly cross-platform and has taken that capability beyond the mobile space and into the space, the PC and game console space, right? The game console vendors themselves, the Sonys, the Nintendo, and Microsoft, they all have their own solution for crash and error reporting for games that are released on those platforms. Backtrace integrates with those and consumes the same types of crashes. We're also middleware partners with the game console vendors. So you can be sure that Backtrace does support your platform and is certified with the middleware vendor or with the vendors that you are using and delivering your games on. So Backtrace not only provides support for these types of errors that you see in the gameplay, but we also integrate to your CI/CD pipelines, helping you catch unit test failures, build failures, playtest errors, and more. What makes us very different is that we've designed and built a purpose-designed database that was created for analytic workloads on game stability data. What that means, it's really focused on high cardinality information. We consume a lot of context when a crash and error occurs. That includes everything from the scene that was being played to the device drivers that are being used to the process age or how long the game has been played. Hundreds of these attributes can be collected. And we provide a database that indexes and allows you to do analytic workloads on this data. This is how we help people prioritize by the dimensions that are most important to them. The other key thing with Backtrace is that we're integrated into the tools that people use on a daily basis. We'll allow you to alert your team via Slack or Microsoft Teams, or even channels like Discord, or via email or IRC. Any channel that you can communicate and collaborate with, Backtrace will plug into. We do the same for issue and ticket tracking systems, so Jira issues, GitHub issues, other issue tracking tools are supported. And then source code and version control systems. So your Gits, your perforces, SVN as well, are all types of source control systems that Backtrace can integrate with and expose to developers so that they can see what lines of code are crashing and who might have last changed that line of code. Backtrace is really the only tool in the market that provides this type of comprehensive solution around game and crash reporting. And that's what we mean when we talk about next generation crash reporting. Let's dig in for a moment to how Backtrace plays throughout the game development lifecycle and throughout kind of the build pipeline, if you will. The phases at the bottom of your screen here are common in the software development world, and we see analogies in the game development world as well. You have phases where you're planning and coding. You have a small phase where you build your game, and then it's out for testing, either black box testing or play testing. Eventually it gets deployed to your players, and then you have to operate it. You have to monitor it and make sure that it's stable and that you are continuing to provide good experience and new capabilities, perhaps. And so this is a common flow that all games kind of go through. Backtrace is integrated throughout this process to capture errors and crashes as they're occurring, anywhere from testing on, And then while you're planning your release cycles, we help you prioritize the issues you should fix. And then when you're actually coding and building, we help you resolve or root cause those issues with easy-to-use web-based debuggers that provide deep introspection and detail so that you know how to root cause and fix an issue. And that's kind of how Backtrace really plays and helps you increase the quality and velocity of your game development lifecycle by helping you throughout this process by capturing, prioritizing, and helping you resolve the errors that matter most. So let's talk about how we integrate Backtrace into your game and what it looks like to you as a programmer. Backtrace provides a lightweight library that is installable via the Universal Package Manager into your game. Once installed, it can catch any of the unhandled exceptions, general errors, or any native crashes and hangs that occur in your game. It'll catch those and submit them to a backend Backtrace instance that you and your team has access to. As we mentioned before, we support all of the popular platforms. We're fully cross-platform. That means iOS and Android on mobile, PC and Mac for PC-based games, Windows and Mac there, and all of the game consoles. Again, Backtrace is a certified middleware partner with Sony and Microsoft and Nintendo, as well as with Google for the Stadia platform. We also support WebGL. So wherever you deploy your game, Backtrace is there to provide support. The type of support that we're providing and what are we doing? On the client side, when an error occurs, we capture the error. We provide facilities to scrub information. If you want to scrub away personal identifiable information, that can occur. And we'll also allow you to capture as much custom and system metadata as you like. By default, we collect a lot of information around Unity information, so what scene is being played, the object map if needed, and a lot of hardware information, what operating system is being used, what graphic card is in use, what graphic device driver is in use. We'll also collect all of the modules that were loaded in the system. So all of this data is collected by the Backtrace Unity plugin in your game. When that data is submitted to Backtrace, there are a set of grouping or deduplication rules that we use to normalize these call stacks. That is kind of the secret sauce. It's a way for us to accurately group and represent issues that have the same root cause, but might have different paths to get there. Okay? Once that data is ingested by Backtrace, we give you the ability to query on it, to group by any dimension, and to aggregate any of that data. And in a few screenshots, I'll show you what that means, right? Other platforms, what you'll see and what you're used to probably, are grouping by fingerprint, right? The normalized error itself, and maybe by version, or maybe by operating system. Backtrace is fully flexible, so we allow you to define the key value pairs and the attributes you want, and allow you to pivot your data and group that data by those attributes. We'll show you more in a bit. So a little bit more about the detailed context that we're collecting. When Backtrace Unity runs in your game, it generates what we call a Backtrace report object. That Backtrace report object has a lot of the information that's listed here. So first off, the call stack and the stack trace. And we're going to include function names and line numbers wherever possible. Okay. For those of you who work with Unity quite often, you understand some of the interpreted languages or some of the ways that the languages can be compiled, specifically with IL2CPP. There's sometimes there's a lack or an inability to access line numbers. We're still working on that as well. But in other situations, such as mono builds or native crashes on your Android or iOS devices, line numbers are possible. So in our report objects and in our symbolication functionality, we will include those line numbers when we can get access to them. Other information that's included here includes system metadata, so we'll get GUID or unique identifiers for the device, operating system version, memory usage. That's really interesting. Some solutions will allow you to capture how much memory is available on the device and maybe how much was allocated to the virtual machine or how much memory was allocated to the game engine, but very few, if any, other solutions allow you to gain access to what memory is actually being used. So memory usage and some of those details, the dynamic memory usage of the system is captured by Backtrace, and that's very unique to us as well. We're also capturing process age. I mentioned before startup issues. These are very important for people to prioritize and understand which crashes might have happened in the first minute of gameplay. And if you want to prioritize those, maybe be proactive and reach out to those users and let them know you're working on the problem. We also allow you to capture a lot of custom metadata. So application version is a common one. I've mentioned scene information before, device drivers and loaded modules. Lots of this data is also available. In addition, Unity users and those who've used cloud diagnostics in the past might be used to things like getting the last n number of log lines or screenshots before the crash, or attachments of the player.log file. These are all available through Backtrace as well. And finally, there's a lot of detailed context that's needed when the engine itself crashes or a third-party plugin crashes. We call these native engine or third-party plugin crashes, and Backtrace has handlers to allow you to collect those crashes and make use of some of that information. Again, I'll show you in a little bit how we can make use of information about a third-party crash to allow you as a game developer to make some informed decisions of what your next steps should be. So the ability to collect the data that you want, combined with a powerful database, allows you to prioritize based on the dimensions or the criteria that are most important to you. Here, I'm showing you a screenshot of a Backtrace instance and a few really key and useful capabilities. First, the filtering. We allow you, in this case here, to filter by an error that is occurring on a specific GPU. Now, what's interesting about filtering, there's two things here. One, we have system-level information that's immediately available to you for searching. But two, the set of operators, filter operators, that are available here are very vast. So we can filter with equals or not equals, contains expressions or not contains. You can filter with regular expressions or inverse regular expressions. So this gives people a lot of flexibility. We often see folks filtering not only by GPU and attributes, but by functions in the call stack so that they can identify certain teams that might want to investigate only those crashes. So this filtering ability that I'm showing you up here is really powerful and useful. There's also a few shortcut filters on the right here for status, assignee, and tag. All of the errors in Backtrace can have a status assigned to them. So you can easily, as a technical director, go through and see which are open, which haven't been assigned to anyone, what's new and needs to get triaged. You can also see those that are in progress or working, and those that should have been resolved. Also, assignment and linking to systems like Jira or other system ticketing systems is fully available. And then there's also ad hoc tagging. So you see here invalid use site or core team or hardware failure. We see people using this just to quickly tag and identify crashes in a way that's interesting to them. And then finally, down in the bottom left here, I'm showing you a normalized call stack. Again, what Backtrace does is we have a grouping and deduplication system that will go through your stack trace frame by frame and remove all of the items that may not be useful to root causing the problem. So if your if your system uses an event loop, the normalization system might remove the event loop from the faulting signature because that may not be the error that happened. Right? Here we have raise exception at the top, which is the function that was used to raise the error, and then right below it, kind of the function that caused the error. Right? So from here, an engineer is going to open up a debugger view and look in more detail to see what errors might have been occurring. Once you as a technical director are reviewing this information, we give you a lot of actions that you can take in support of resolution. So I'll start off with statuses. Over on the left, you can see open, and then some other statuses: mute, mute until, resolve, and resolve until. What these allow you to do is say, hey, we're going to mute this error because it's not something that we're worried about right now. But if it occurs maybe in 7 days, alert us at that point. That's the ability to mute until a certain time period. Or we allow you to mark something as resolved until it's seen in a future build, meaning you fix something in version 3.1. If you see it again in version 3.2, reopen it and mark it as a regression. That's a really useful capability for folks to make sure that the issues that they fix stay fixed. So this is what we call regression detection. We also allow you to link to your issue tracking systems, as we said before. Your Jira, your GitHub issues, any of those types of systems. Backtrace also provides two-way synchronization here. So we can ensure that states, open and closed, are kept in sync, and assignees are kept in sync as well. So now you can use Backtrace and your issue tracking system to make sure that issues get fixed by the right person. We can apply these tags or unstructured comments so that you have more ability to collaborate on the issues. And there is an ability to merge and unmerge. If you see multiple issues that are similar and have the same root cause, you have the ability to manually tie them together. Let me show you a little bit about how you can visually aggregate some of this data and look at a large corpus of information. In this case here, I'm visualizing instability by code path. I'm using a flame graph view so that I can view all of the different stack traces responsible for hangs or ANRs, application non-responsive, in my system. So in this case, I've filtered down to the last 7 days, and I'm viewing ANRs or hangs, and I see I have 511 errors here. When I use this visualization, what I'm looking at down below is the call stacks for those 511 errors. So this is a nice way to visually look at a relatively large corpus of data. And the value that we're providing here, when you zoom in and look at a set of these third-party subsystems, the MoPub system here, we can see that in aggregate, if I combine these all together, 20% of my hangs or ANRs here are caused by this subsystem. So now, as a product owner, you have some new intelligence. You can decide if you want to report these to the third-party developer. You can see if you can use a different function that the developer provides that doesn't crash, or you might even replace that with another solution. So now, with Backtrace, you're able to see this new actionable intelligence, new information that allows you to identify where different hangs or different other types of problems might be manifesting in your game. Let's talk a little bit more about the ability to query some of this data. So Backtrace provides, as we said, a flexible query system. Here's a way that you can provide a custom view across instability of all of your games and include a distribution of how many unique errors there were. So at the top here, I see the game NW with 280,000 total issues. I can see the breakdown of how many unique fingerprints there are, which versions of my game are crashing, how many unique users are being impacted, and even when certain crashes were introduced. So here, two very interesting things that we can see. One, 15% of all of my crashes originate from a bug that was introduced on a certain date in a certain release that we can see here. The other interesting thing is that you can also see that 66% of the crashes are caused by a single user, right? So this allows you to understand which user you might want to proactively engage with, let them know maybe there's some incompatibility. If you drill into their errors, you'll be able to maybe determine why they're seeing so many issues. And the other thing here is now you know which error you might want to investigate because it's the one that has the most impact. Finally, this flexibility for querying allows you to really build custom dashboards. And the other thing we want to highlight here is these dashboards aren't just locked inside of Backtrace. We can export all of this data through information that we call metric exports, and we can even import metrics that you're collecting for things like successful game sessions started, number of minutes played, number of battles played, or anything like that, so that you can start to generate stability scores and understand how many errors are impacting how many sessions you've started, or how many errors you've seen per minutes played. All of that data becomes available to you and customizable into these dashboards. So let's talk a little bit about how different studios are using Backtrace. Backtrace is used throughout the gaming industry, not only Unity Engine and Unreal Engine, but custom engines as well. Folks like Roblox and EA Respawn make use of Backtrace throughout the game development lifecycle. Roblox is a great example of a company that uses us whenever they're doing upcoming feature launches. Roblox is a great example of a company that uses us whenever they're doing upcoming feature launches. They practice the notion of feature flags, where they enable new features to a small subset of their users. They track the feedback and the stability, and when it reaches a certain level, they decide when it's ready to be released to a larger population. Respawn uses Backtrace as they're releasing new patches to their games and knowing when a new patch is ready and at the right stability level based on their testing. Other studios like Amazon Game Studios use Backtrace from the very beginning of their game when they're developing new titles. As soon as a game leaves the developers or their programmers' desktop, they want to be able to capture errors and start to fix them. So throughout the cycle, sometimes it's used when you're releasing a new game. Other times it's used when you're starting game development very early on. Finally, we see folks using us as they enter gameplay testing. So the gameplay, the testing, the testing phase of your game development lifecycle is very important. You're going to capture feedback from your players, and that feedback might include errors and crashes. So integrating Backtrace to support them during the gameplay testing experience allows them to really respond to those errors quickly and get the game ready for the next production release. So to close, let's summarize what we've discussed. Game errors and crashes have a direct impact on your ability to retain users. As we said before, they are annoying to players, they'll cause players to have a bad experience, and if your game is not stable, it has more of a chance to have a lower rating, which doesn't open up as much as the market to you. So for this reason, solutions around crash and error reporting have existed for mobile games, and even for platform vendors like Sony and Microsoft and Nintendo. But there hasn't been a real cross-platform solution that allows you to tie this together and analyze this data in useful, interesting ways. The Backtrace system, backed by our custom-designed database, is really what makes this tool next generation and allows game studios to more quickly address the issues that matter to them most by understanding where they're occurring, who they're impacting, and what the root cause might be. Thank you for your time. We hope you enjoyed the session. More information is available on unity.com/products/Backtrace.